On July 28, 2026, the United States government banned the import of Chinese humanoid and four-legged robots, citing a threat to national security. 24 hours later, China didn't file a complaint. It didn't issue a statement. It launched a national mobilization plan to put more than 10,000 humanoid robots to work inside real factories, warehouses, and hospitals before the end of the year. Not 10,000 robots built. 10,000 robots actually deployed, actually working, inside actual production lines, in 5 months. This is one of the fastest, most coordinated state responses to a trade restriction that the technology world has seen in years, and almost nobody outside the industry is talking about it yet. 7 different Chinese government bodies signed onto this program simultaneously, including the ministry that handles emergencies and disasters, and the country's central bank. Think about that combination for a second. Emergency management and the central bank both attached to a robotics policy. That alone should tell you this isn't a typical tech subsidy. By the end of this video, you'll understand exactly what China is building, why it's structured completely differently from anything the West has tried, and why the timing of this announcement was almost certainly not a coincidence. Hit like if you want more breakdowns like this. It genuinely helps the channel grow. Let's get into it. To understand why China moved this fast, you have to start with what happened one day earlier. On July 28th, the U.S. Federal Communications Commission announced a formal ban on new imports of Chinese-made humanoid and quadruped robots, framing the move explicitly around national security concerns, the same language that's been used for telecom equipment, for surveillance cameras, and now for robots that can walk into a building on their own legs. This wasn't a ban that came out of nowhere. It landed on top of a market reality that the West has been quietly uncomfortable with for a while. By most expert estimates, Chinese companies, firms like Unitree being the most visible name among them, control somewhere around 85% of the entire global humanoid robotics market as of 2026. Not 85% of Chinese domestic sales, 85% of the planet. That number is the real story behind the ban. When one country controls that much of an emerging, physically embodied AI technology, machines that can move through the same spaces humans do, carry things, open doors, operate near sensitive infrastructures, a security response was, in hindsight, close to inevitable. The US ban was designed to slow that dominance down by cutting off market access. China's answer, coming exactly 1 day later, was designed to make that access irrelevant by building a self-sufficient robot economy that never needs to cross a border in the first place. It's worth sitting with the timing here for a second, because timing is doing a lot of the storytelling. Trade bans typically take months to draft, get legal sign-off, and clear internal review before they're announced. A national industrial mobilization program spanning 7 government agencies typically takes even longer to coordinate. The fact that China's response landed within 24 hours strongly suggests this wasn't a reactive scramble. It suggests the plan, or at least a version of it, was already sitting on someone's desk in Beijing, ready to be activated the moment a justification like this ban arrived. Here's what makes this program genuinely different from the last few years of humanoid robot hype, and it's a shift in language that the government made completely explicit. For the past several years, the defining images of humanoid robotics have been backflips, dance routines, and choreographed demos on trade show stages. Impressive, viral, and almost entirely useless in an actual factory. Beijing's new directive draws a hard line under that era. The official framing is blunt. Robots need to work, not dance. The demonstration era is officially over, and the production era has officially begun. The mechanism driving this shift is worth understanding, because it's not a typical top-down subsidy program. It runs on something China calls an open bidding system, sometimes translated as tearing off the tab. where the government publishes a list of extremely difficult technical problems, and companies, startups, and research institutes publicly compete for the right to be the lead solver on each one. It's less like a government grant application and more like a bounty board for national infrastructure. And the scale attached to this mandate is concrete, not aspirational. More than 10,000 humanoid robots are supposed to be operating inside real economic settings, factories, warehouses, hospitals, before 2026 ends. On top of that, the government has published a list of over 100 priority tasks these robots are expected to actually perform. Assembling electronics, maintaining equipment in hazardous production environments, standing duty in disaster zones, working inside hospital wards alongside medical staff. This is a checklist for utility, not a highlight reel for a keynote. And notice what's missing from that list of priority tasks. There's no mention of stage performances, no mention of consumer novelty products, no mention of anything designed primarily to go viral online. Every single one of the 100+ scenarios is tied to an existing economic activity that currently requires a human being to show up and do the work, which is exactly the point. This isn't a plan to build robots that impress people. It's a plan to build robots that replace, or at minimum supplement, specific line items in a factory's labor budget. Here's the part of this plan that actually solves the real-world problem that's been quietly killing humanoid robot adoption everywhere else in the world: cost and risk. A single advanced humanoid robot can run well into 6 figures. And for a factory manager, buying one outright means betting a huge capital expense on a technology that's still maturing, still prone to breakdowns, still unproven at scale in your specific environment. China's solution is a leasing model the program calls Humanoid Robot as a Service, or HARAS, deliberately mirroring the software as a service model that reshaped the entire tech industry 2 decades ago. Instead of purchasing a robot, a factory rents one, paying based on completed work output rather than a fixed monthly fee. If the robot breaks down, that's the leasing company's problem, not the factory's. If the robot underperforms, the factory simply pays less. This single structural choice removes the single biggest psychological and financial barrier that's been slowing humanoid robot adoption across the entire global industry: the fear of betting a large lump sum on equipment nobody has stress-tested at scale yet. It's a genuinely clever way to accelerate deployment numbers without waiting for the underlying hardware to become perfectly cheap or perfectly reliable first. And there's a second layer to this that's easy to miss. An HRS model doesn't just lower the barrier for factories to try robots, it also gives the government and the leasing companies a constant, real-time stream of performance data from thousands of robots operating in genuinely different environments, from electronics assembly lines to hospital corridors. That data becomes fuel for the exact embodied AI training loop the rest of the program is trying to build. In effect, every leased robot isn't just doing a job, it's also quietly generating the training data that makes the next generation of robots better at that same job. The program specifically calls out companies like CADL, BYD, and Foxconn as the kind of large-scale domestic manufacturers expected to absorb a big share of this initial robot workforce. Giant, capital-rich firms that can afford to be the first real-world testing ground at a scale small factories simply can't. There's a strategic logic here, too. Beyond just economics. By seeding the earliest, most visible deployments inside companies the government already has deep relationships with, Beijing gets a controlled environment to work out the inevitable early failures, the awkward breakdowns, the misjudged tasks, the PR risks of a robot malfunctioning near a human worker, well away from smaller, less forgiving businesses that might abandon the technology after a single bad experience. Underneath the flashy deployment target sits a much deeper technical roadmap organized into 6 broad technology pillars and 24 specific engineering tasks. Essentially, the entire stack a humanoid robot needs to function outside a controlled demo environment. Pillar 1 is embodied AI, building neural network brains capable of understanding and navigating physical space, planning multi-step actions, and learning on the fly rather than following pre-programmed routines. Pillar 2 is atomic and precision assembly, engineering actuators, sensors, and servo motors accurate down to the micron, and in some cases, effectively down to atomic scale tolerances, for robotic hands and joints that need to handle delicate manufacturing work. Pillar 3 is brain-inspired computing. Neuromorphic chips designed to cut a robot's power consumption by an order of magnitude, which matters enormously for machines that need to run untethered for a full working shift. Pillar 4 is industrial software and big data. Platforms built to safely collect training data directly off real production lines, essentially letting robots learn by recording actual human work shifts and turning that footage into training. Material. Pillar 5 is specialized equipment. Autonomous systems engineered to survive extreme environments, high heat, radiation exposure, underground mining conditions, the places where sending a human is either expensive or dangerous. And Pillar 6 is financial and digital infrastructure. Building fintech systems that let machines transact directly with other machines, machine-to-machine payments, without a human approving every transaction in the loop. Put together, these 6 pillars read less like a robotics roadmap and more like the blueprint for an entirely new category of industrial labor. And it's worth noticing what's absent from this list, too. There's no pillar dedicated purely to robot appearance, personality, or consumer appeal. Every single one of the 24 tasks underneath these 6 pillars is aimed at making a robot more useful in a workplace, not more likable in a living room. That's a deliberate signal about who this program is actually being built for. Factory owners and hospital administrators, not consumers browsing a gadget store. Now, the part that deserves a clear-eyed look instead of pure hype. A government announcement with an aggressive number attached to it is not the same thing as 10,000 robots actually functioning reliably on real production lines by December. China has a well-documented pattern of setting extremely ambitious industrial targets and then adjusting or quietly softening them as deadlines approach. That's not a uniquely Chinese habit. It's common to ambitious state-led tech pushes anywhere in the world. Getting a humanoid robot to reliably perform a real job, hour after hour, in an unpredictable factory environment, is a dramatically harder engineering problem than getting one to perform a scripted backflip on a stage, which is precisely the gap this whole program is explicitly designed to close. And which means, by the government's own framing, that gap hasn't fully closed yet. There's also the open question of whether the underlying hardware, batteries, actuators, joints, can survive the wear and tear of continuous industrial use at the cost points needed to make the robot leasing math actually work for factory owners. And the US ban itself, while a real regulatory action, only blocks new imports into one country. It does nothing to slow deployment inside China's own borders. Nor does it touch the roughly 85% of the global market these companies already hold outside the US. So the honest picture is this. The target is real. The funding is real. The coordination across 7 government bodies in under 24 hours is genuinely remarkable. But whether 10,000 robots are truly earning their keep on real factory floors by year's end, or whether that number gets revised quietly in a footnote sometime in early 2027, is still an open question nobody can answer yet. It's also worth remembering that deployed is a flexible word in a lot of state industrial reporting. A robot counted as deployed could mean anything from fully autonomous and load-bearing on a production line to a pilot unit doing a narrow, supervised task under constant human oversight. Until independent third parties start publishing verified numbers from actual factory floors, the 10,000 figure is best treated as a target to watch, not a fact already in the books. Step back. And this isn't really a story about robots doing backflips versus robots doing warehouse work. It's a story about what happens when a country that already controls the overwhelming majority of a critical emerging technology gets hit with an access restriction, and instead of slowing down, decides to build an economy that no longer needs that access in the first place. Sanctions are designed to create friction, to buy time, to slow an opponent's momentum. What happened in the 24 hours between July 28th and July 29th is a case study in how quickly that friction can be answered, at least on paper, by a state willing to mobilize 7 different agencies overnight. It's also a preview of a pattern that's likely to repeat well beyond robotics. As more emerging technologies become strategically important enough to trigger security-driven trade restrictions, expect more responses that look exactly like this one. Not diplomatic protest, but an immediate pivot toward domestic self-sufficiency, announced within days rather than negotiated over years. The real test isn't the announcement, it's December. It's whether those 10,000 robots are actually standing on factory floors doing real work, or whether this becomes one more ambitious target quietly adjusted down the road. Either way, the direction of travel is now unmistakable. Humanoid robots are being pulled out of the demo reel and pushed into the supply chain, on a timeline measured in months, not years. What do you think? Is 10,000 working robots by December realistic? Or is this China setting a target it already knows it will miss? Let us know in the comments. And if this kind of breakdown is useful to you, subscribe so you don't miss what happens when December actually arrives.